graph traversal algorithms. See, in tree structure, in tree data structure, we have studied 3 different types of traversals. When you have a tree like this, you have different ways of traversing a tree. In specific 4, but we say no, pre-order, then in-order traversal, post-order traversal. Along with these 3, we have also studied level order traversal. What are these? Since trees and graphs are non-linear data structures, right, we have to follow some specific pattern to access all the elements of a tree or graph. Okay. For tree, we know we have 3 different techniques, in fact 4, right. Why we need these traversal techniques? We use these traversal techniques to visit every node of a graph. See, we are storing data in a tree form or in a graph form, and I want to search for the data, mainly for searching. Does the data exist in that or not? When I am searching or when I am visiting a node, I have to follow some pattern. So, we are having 4 different patterns in trees. Like that, in graphs also, we are having some specific traversal techniques. In graphs also, we have some traversal techniques which are very widely used in solving bigger problems. Okay. So, in graph, what we do? We follow some technique. This is a graph, for example. I have something like this. I want to visit every vertex. Okay. So, when I am visiting, how should I go? Should I go this way or this way first? Should I start from 1 and suppose this is the numbers? Should I start from 1, 2, 3 or 4, or should I go from 1, 4, 3 and 2? Right? We get multiple types of formats there. We can go in any fashion. That's why, to have a standard practice, we are having 2 different graph traversal algorithms. Okay. So, what are those? Let's study. So, to solve problems on graph, we need a mechanism for traversing the graphs. Okay. Graph traversal algorithms are also called as graph search algorithms. Why are we traversing? Because I want to search an element. Only when we need to search an element, we do traversing. Okay, right. So, like trees traversal algorithms, these 3, we know these 3. In trees, we have these algorithms. Graph also has some sort of algorithms. Okay. Graph search algorithms can be thought of starting at some source vertex in a graph and searching the graph. It is also same like in order, pre-order only, starting at some point, following some strategy and visiting the nodes. Okay. So, in standard, we are having 2 different types of traversals, depth first and breadth first. Depth first traversal and breadth first traversal. Before we go detail into these graph algorithms, let me give a simple example. So, when you are having a graph like this, some graph is like this. What you try to do, in this depth first, you will understand this much better. Okay. Let me represent them as trees. Okay. Let me give this example. This is again, assume this is a graph. Okay, right. So, depth first traversal means first start from root, then go its left, then again left you go. After that, you come back to top and visit this node, again come back to top and visit this side. Okay, again go left, again come back, again go right. So, depth first means go to the depth element first, go to the depth most element first, like this, go to the extreme depth and then come back always, right. That is about DFS algorithm, depth first, meaning you are going in the leftmost depth, then slowly coming up, going right, like this. This example if I take, right. So, first let us give numbering 1, 2, 3, 4, 5, 6, 7. First visit 1, then go to its depth 2, then go its depth 4. Again from 4, since this is the last one, come back to 2, from 2 go back to right, that is 5. Since this is last one, come back, from there you go back to 1 again, then go back to 3, from there go back to 6 and then 7. Like this you can traverse. This is depth wise, we are going depth most then and coming back. Okay. Same thing for breadth first. BFS means breadth first algorithm. in breadth first algorithm like this, if I have a tree, I am explaining with the tree example so that you understand it easily. If you have a tree like this, right, breadth first is same as
You
your
have 5 minutes
level
remaining.
order traversal. It is same as your level order traversal. What we do here, level order traversal, first 1, then 2, 3, then 4, 5, 6, 7. This is your breadth first search. Okay, we will do it level by level. Whereas a DFS, we go deeper into the bottom level and then you keep coming back, right. So, this is about graph traversal techniques. We will study about both of them in detail with an example. Let us discuss about depth first search, DFS algorithm. Like I said, no, when you have a graph structure, you go depth wise first and then you come back towards the its root element. Okay. So, DFS algorithm works same as your pre-order traversal of trees. Okay. What is pre-order? First you will be visiting in pre-order, you will be visiting root and then right and left, left and right, root, left and right. This is your pre-order. So, same way it works, meaning it uses a stack. Okay. So, let us see the algorithm theoretically before we go and understand the with an example, or let us go to an example first and then come back to the algorithm. I will just quickly give an overview here. See, this is a graph. I have a graph with me, right. So, you are maintaining a array like this. You are maintaining a table, we can say a table or an array, right. So, first begin it from A. I am talking about depth first. So, we will go in the whole depth and then we will come back, we will do back traversing. Okay, we will do back traversing. Okay. So, what we try to do here, first I will be visiting A. From here I will go to the its next child, that is B. I will be visiting B node. So, whenever I am visiting a node, I am updating the number to 1 here. See, first I visited A, then I am visiting B. Okay. Second time I am visiting B, I am making this as 1. Then I will be visiting C, the third node, because I have to go depth wise. No, in the first line I have to go, then I have to come back traverse and again go to second line. That is what we do in depth first search. Okay. Then after then I will visit C, I will mark C as 1. Then I will visit D, I will mark D as 1. After this, do I have anything? No. Whenever you do not have any element here after this D, from here you have to come back. Okay. From here you have to come back. See, after visiting D, you will go back to C. Okay. See, backtrack from D, you have to go back from D to C, then go to the next level E, From here, do we have any path from E? Yes, I will go depth wise, that is I will go to F, After F, do I have anything? No, I do not have anything. Again you will come back to E, then you will go to the next level, that is G. We will be visiting the node G. Again, after this, do I have anything in this depth? No, I do not have anything in this depth. Do I have anything down the straight forward like this? No, I do not have anything. Then you will go back from here. Okay. Now, after visiting this side, you will look for the top side. Then you go for H. You will be visiting for H. From H, you will go back to B and then you will come back to A. But this is not required, because from this H you can come to B and again you can go back to this E and then to C and again go back to your original A. How you are coming back? You see, after visiting H, you are going to B. This is already visited. So, come back to its parent. From this again go back to C, go back to B and then to A. That was the path which we used to traverse. So, we have to go back in the same order. Okay. So, this is just a demonstration with a small example. What we are trying to do, again let us see this. First we are beginning, now let us see the algorithm and come to that example again. Initially all vertices are marked as unvisited, meaning I have kept everything as 0 initially. Okay. Then the DFS algorithm starts at a vertex u in the graph. I can start from any vertex u in the graph, right. By starting at vertex u, it consider the edges from u to other vertices. So, when I start from A, what is the only path I have? I can go to B only. Then, if the edge leads to an already visited vertex, then backtrack. From this, if this is already visited one, go and check the table. Is it 0 or 1? Is it 0 only? Then visit it. If it is 1, again come back, backtrack. Okay, again backtrack. So, from A, I go to B, because B was not visited, B was containing 0. So, I visited B like this. So, like this I am visiting C, I am visiting D. After D I do not have anything, that is there here in the C. If an edge leads to an unvisited vertex, then go to that vertex and start processing from that vertex. So, from A, if I am going to unvisited one, okay, visit it nicely, no problem in that. That means the new vertex becomes the current vertex. Now, this is my new vertex. Now, B becomes my new vertex here. After visiting, B becomes my new vertex. Then follow this process until we reach the dead end. At this point, start backtracking. See, I am visiting B, then I am visiting C, I am visiting D. After D, do I have anything to go? No. Then backtracking means come back to its parent node. Come back to its parent node, right. Then the process terminates when backtracking leads back to the starting vertex. Once you reach back to the same original vertex where you started, there we end the algorithm, right. This is your depth first search technique. Again, now let us after understanding this algorithm, let us go and see the example once again. See here, this is the graph given to us. So, first initially everything will be 0. Okay. This table I am maintaining to know whether it is visited or not visited. I visit A, I make it 1. From this arbitrarily you choose 1, from there you go to the its adjacent one. Any direction you can go in any direction. Here I have only one element, right. In that case you go to B, because there is only one path, okay, right. Go to B, check, is the B visited already? Is this node B visited already? No. Why? It contains 0. So, it is not visited. It is not visited. So, you visit this and make this as 1. Now, from this where you have to go? After B, you have to go depth wise. So, you will go to the node C. Is it visited? No. So, make that also as 1. Okay. Make that also as 1 and visit C. After this, from C you go to depth wise D. Is this visited? No, it is not visited. So, visit it and make this as 1. Next, after visiting D, then again, do we have anything after D? No, this is the dead end. So, the algorithm says whenever you reach dead end, you backtrack, you will come back to C. Now, C is already visited, right. See, you are backtracking to C, which is already visited. Then from here you will go to this path E. Why? This is already visited, this is already visited. You will go to E here. Now, in E, is it visited before? No. So, visit that E. Okay, make that as 1. When you visit E, make that as 1 like this here. After this, go depth wise and visit F. Visit the F. After visiting the F vertex, okay, make that also 1. Now, we have reached a dead end. We do not have any path from F. In such case, again I have to go back to the original E. Okay, I have to go back to the original E. From here, go to the this side. From here, you can go either this way or this way. Choice is ours. Okay, you can follow any path. There is nothing that you have to go this way only, right. You can go to H also. Okay. So, here in this case we are going to G. So, once I visit G, I reach a dead end, then backtrack. After backtracking, you have one, this is also done. Then there is a path here, you visit that path. So, I will be visiting H as well. After visiting H, I can go to B, but I could see this is already visited because it contains 1. Then again backtrack, come back to again backtrack. From here, from where did you come here? Again backtrack, again backtrack, again backtrack. That way, if you reach the same location, we complete our depth first search algorithm. Okay. So, generally in exams, they will ask you to given a graph, show the steps of depth first search. So, you have to show something like this. So, when you have a graph like this given to you, first initially only this A, then A to B, first second step, then third step A to B to C. Then after this you have to show A, B, C and D. Then again after that you have to show A, B, C, D and then E. Like this step by step demonstration you have to show for the traversals. Okay. I hope you understood depth first search algorithm. What we are trying to do, we are starting at a vertex. Okay, we are maintaining a flag whether it is visited or not. If it is visited, you again backtrack. If it is not, visit that and from there you start processing. Okay, this uses a stack. Why does this uses a stack? Why? Because when you are visiting a vertex, you are putting that in a stack. A is completed, then you go to B, then you go to C, then you go to D. After this D, again you go back to C, because this is dead end, you go back to C. So, you remove this D. You have the top is C. From C you go to E. So, E is inserted. Okay. From E again you go to F. After F again you go back. So, you delete this and go back to E. From E you go to G. After G again you backtrack. You come back here to E. Then you go to H. From H you go to B, but I cannot go to B because I already visited. So, I will not go. I will come back to my E. From E I will go back to C. This is already visited. So, I will remove this. From C I will go back to B. From B I will go back to A. Like this we are pushing the elements into the stack. Okay. So, this is the approach of how depth first search algorithm is working, right. I hope you understood about this DFS algorithm. So, let us see the next algorithm, breadth first search, right. This is same as our level ordered traversal. Okay. So, in trees we know level ordered traversal, when you have a tree like this, we visit level by level. So, first this element, then these two elements and then these four elements. We do visit in each level. Okay. We do level by level traversal, right. This is our BFS technique. We always follow this level order traversals in BFS. What we try to do, how we are doing that? We are maintaining the details in a queue. So, DFS, sorry, this is BFS here. DFS uses stack data structure and BFS uses queue data structure. Okay. They use DFS uses stack and BFS uses queue data structure. Before we see the algorithm, let us go to an example and then come back to the approach, how we are trying to do. Okay, right. Let us see the algorithm. So, same graph I will take here and I will try to see how we apply the breadth first search technique here. Okay, just a second. Right. So, this example which we have used for DFS. So, what we try to do here, we visit level by level. Okay. So, first level, this level 0 we have only A, then at level 2 we have B and H, right. So, let us see how we do. Starting vertex A is marked as unvisited. So, this we will visit. Okay. So, vertex A is completed, circled part is level 1. This is there in level 1. Maybe if I draw this in a different format, A looks like this. From there is B, from there is B, and from B I have C and also I have H, and both are connecting to E like this, and from C I am having D, from E I am having F, and this is having G. This is the graph actually. If you see this one, if I just tilt it and draw it neatly, it becomes like this: A, then B. B has two paths, that is C and H, both are combining to E again, and C has a child D, E has a child F and G. So, this is our level BFS. Now, by this you can easily tell the level order traversal. Okay. What we are trying to do? First we are visiting A. After that, this is our next level. So, the queue contains B. The queue contains B. So, we visit the B node. We visit the B node. Then after B, which two elements are there in the next level? C and H are in the next level. So, the queue will contain now C and H. How will I know? How will I know that there are C and H? Because the children of B are C and H. They too will come into the queue. Okay. These two will come into the queue, C and H. Now, in this I will visit C and H. After that, after visiting C and H, then which are all the children of C? Which is the children of C? Okay, see this diagram. These two are in same level, D and E, right? So, the children of C is E, here it is D, and for H it is E. Why? See what elements are there in the queue? C. C's child is D, okay, and E. H child is E. So, this is common. D, E are the same level. So, these two I have to visit. Now, what after visiting these two, which one do you think I will visit? Do D have any children? No. E has any children? Yes, F and G. So, those two we will be visiting. See, F and G will be visiting. Like this, we try to visit it level by level. Okay. Now, let us understand this by taking a queue. Right. See, this is the case. My queue will be empty. Queue will be empty. Okay. So, I will insert that A into the queue and I will visit it. Then which child in which node is the children of A? How will I know the children of A? I think you are aware of this. When you can store them, tree kind of a structure, we know we can store them in 2i plus 1, right? 2i plus 1, 2i plus 2. Okay. In that format, see, indexing 0, 1, 2, 3, 4, 5, 6, 7, 8. Why the 1 is empty? Because it has only one child. Okay. That is why this is empty, right. So, from A you will know which one is the children of A, that is B. So, in Q I will delete this and I will put B here. A is visited. Now, the next level contains only B. Next, after this, which elements I am visiting? Which is the children of B? Children of B are C and H. So, this will be deleted, C will come, then H will come. Now, find out the children of C and insert it back here. Okay. So, if you see again, this is my Q, first insert A, then insert B, the children of B, then which are all the children of B? C and H. Next, which are all the children of C? It is D, for H it is E. Then children of D, nothing. Children of E, F and G. Like this, you will be filling elements into the Q data structure and you will be deleting one by one. First A, then B, then C, then H, then D, F, G. Okay. So, we use this Q data structure here to implement the breadth first search. Logic is very simple. Given a graph, okay, given a graph, I will take the simple example to show you the BFS. This is A, B, C, D. This is also a graph, right? I can apply here also breadth first search. Okay. So, this way you cannot understand which one is in the top level. So, if you just tilt it, no, like this. Now, you understand it very easily. This is A, this is B, this is D and this is C. So, A, then B, D and C, right. Breadth first traversal, whichever is in the same level we print that first. Okay. A, B, D, C. Any way you take, this way you take, answer is A, B, D, C. This way you take, it is A, B, D, C. Any order you take, you will get the same answer in the BFS. Okay. So, when you have a graph with you, you can try to convert that into the BFS technique. Okay. So, these two are the very important graph traversal algorithms, DFS and BFS. Okay. DFS uses stack and BFS uses queue data structure. Okay. Using this, we try to visit the vertices and traverse the graph.